what is decomposition? A breaking down of a problem into sub-parts, smaller parts. So that process is what we call it as a decomposition. Suppose if I consider an algorithm, what is an algorithm? A step-by-step solution to given a problem. Okay, that's what I will call it as an algorithm. If I have any different parts in the algorithm, to give a name for that parts, I will be using something called names. Okay, that names is what I will call it as identifiers. Hello everyone, I welcome all of you to the yet another interesting session. So in this session, I will be discussing about introduction to the problem solving and getting started with Python. So without wasting much of your time, let's get into the session. So guys, in this session, I will be discussing about what exactly the problem is all about and how do I solve the given problem in a different stages. That's what I will call it as a problem solving cycle. Then after that, I will also discuss what is an algorithm and how do I write an algorithm. If I take an algorithm, so how should I write an algorithm is what I will also discuss. Along with that, I will also discuss the importance of writing the flowchart. How do I write the flowchart and what are the notations that I have to follow in the flowchart is what I will be discussing. Then after that, a very important point. So what is the advantages and disadvantages of using Python is also there in my bucket today for all of you in this session. So guys, the last topic what I have in this chapter is all about working in Python. So my dear students, when it comes to this working in Python, I will demonstrate live, okay, in my live class how exactly we are using the different platforms to write the Python programs. So without wasting much of your time, let's get into the session. So guys, so this is the detailed structure that we have to solve a given problem. Okay, so I have listed out 10 different stages or steps to solve a given problem. So let's understand this one by one. Okay, so to discuss this, let me take a simple example. All right, so imagine I have a problem. So what is the problem you have, sir? Imagine I have a problem like, I want very good coffee. So that is the problem that I have. Okay, how do I solve this problem? So let's understand this one by one or step by step. So what is the step number one that I have? The first step that I have to do here is understand the problem well. Now, to understand the problem well, what is that I have to do? So first thing that I have to do is, please observe, find what is occurring. So find what is occurring in the sense, in this example, I'm not getting the good coffee. So that is what I'm getting. Okay. So point number one that you have to note. Point number two, what is expected? I'm expecting a good coffee. Okay. So I'm expecting a good coffee, but I'm not getting the good coffee. That is what it is coming to my mind. All right. So then after that, what is the discrepancy between expected outcome and the current outcome? Expected outcome is good coffee, but what I'm getting, I'm not getting a good coffee. So please understand. So have a clarity of what is exactly the problem that you're facing. So that is the first important thing that you need to understand. All right. So understanding the problem very clearly is very important. So that is the first thing. That is the first point to solve any given problem. All right. So what is the next point that we have? Analyze the problem. Okay. So you understood what you are supposed to get and what you are getting. So you understood in the first point. Now you need to understand the problem in detail. So identify the processing components. All right. So if I take a coffee, so what are the processing components that I have? I'll have milk, I'll have water, I'll have sugar, I'll have coffee powder, I'll have stove. So all these things are involved to prepare a coffee, right? So understand, identify the processing components and identify the relationship among processing components. What is the relationship between water, milk, sugar, coffee powder? Understand the relationship between these components. Suppose if I put more water, will it affect the taste of the coffee? If I put more sugar, will it affect the taste of the coffee? If I put more coffee powder, will it affect the taste of the coffee? So understand the relationship between the components that is involved in this process. That is very important. So you are understanding and analyzing the problem in detail. So after analyzing the different components involved in this problem, so we'll move to the next part. So what is the next part that I have? Identify the possible solutions. Okay, you understood. So what is the problem and what are the components that you have? So how it is affecting, what is the relationship between that? And then now you try to come out with the possible solutions. Ideate possible solutions. What are all the different ways that you can solve these problems? So number one, so please think different ideas to solve or to give a solution for a given problem. Then point number 2, check out for your ideas and openness. Point number 3, I will leave it to you. So please imagine and have a creativeness in solving any given problem. Always people will think a big problem can be solved with a simple solution. So please, my dear students, always think in a different dimensions. For your imagination, sky should be the limit. Alright, so with this, we'll move on to the next point that we have. Design the chosen solution. So whenever you have a problem, so now it is very important that you need to think about the solution. Now, how do I solve? How do I give a solution for a given problem? Now, it's very important. Observe here, break the task into subtasks. It's very, very important. So guys, if at all, if you have a problem, the decomposition of that problem is very important. Sir, what is decomposition? A breaking down of a problem into subparts, smaller parts. So that process is what we call it as a decomposition. So guys, now what does I have to do? Why should I have to do this decomposition? So please remember, imagine I have a big problem. Say for example, marriage is a big problem. Okay. So now I need to handle that entire event. So that is going to be very difficult and it's going to be very big problem for me. So to solve this problem, I will divide this big problem into small subparts. Now, for example, in a marriage, I have to invite all the guests and I have to attend catering people and I have to take care of decoration and I have to do all these events. Okay, so now what I will do, so I will divide this into subparts. Say for example, catering, I'll assign it to somebody, invitation, I'll give it to somebody, and decoration, I'll give it to somebody. Like this, each event I will assign, I will decompose it and I'll assign it to every individual that I have. So now my task is becoming very easy for me to handle such big problems. Okay, that is the advantage that we have whenever we have this decomposition. Decomposition in the sense a big problem is divided into smaller subparts. So that is one of the advantages that we have to solve any given problem. All right, so that is the first thing that you have to do. Then next one, decide step-by-step solution. If at all, if you have a problem, so understand and write the solution and prepare the solution step by step. All right, if at all, if you have taken a coffee, now don't dump everything into one vessel in a one single go. So step-by-step preparation will help you to provide a proper solution. So that's the second point that you need to remember at this point of time, to design the chosen solution. All right, so very important point that you need to remember here is decomposition and step-by-step solving the problem. So that is the most important point that you need to remember. Then after that, so what is the most important point? Identify the operations for the solution. What is the operation that I have to perform for the solution? Number 1, so please remember, decide the minimum number of inputs required. Okay, so obviously if I have a problem, so I need to understand what is the input that I have to give to solve this problem. Okay, too many number of inputs will create a confusion and it creates a bias. So for that, I need to reduce the number of inputs in this point of time. All right, so that is the first point. Second point, decide the arithmetic operations that is required. So what exactly that you need to perform? Okay, so choose the proper arithmetic operations which will be related to solve this particular given problem, and then choose the simple and efficient data structure. All right, so I think this will be too early to discuss all these concepts, but still as of now, you just remember data structure in the sense it mainly deals with the space and time complexity. Whenever I'm writing any algorithm, so the most important thing that I have to keep it in my mind is all about it should run fastly and it should take less time. That can be handled with the help of the data structure. So that I have to handle it, that I have to choose it wisely. All right, so that is what I have to do it here. So you have to choose the proper data structure to solve the given problem. All right, moving forward to the next one that we have. All right, so now I have prepared the entire solution. Now everything, all the blueprint is ready. I just have to execute it. All right, so how do I write the program now? Whenever I'm coding the program, it's very important that I have to take care of certain things. So what is that? So please observe, whenever you're thinking of efficient code or whenever you're writing a program, all right, so most important thing that you need to remember is conditional structures. So what is the meaning of conditional structures? I think all of you have studied, all right, so if statements, we have different types of if statements. So you should choose what type of if statement that you have to use and when you have to use. So that is the most important point that you have to take care of it. So that is what I will call it as a conditional structures. If statements, different types of if statements for your solution. So where exactly I have to use if statements and what type of if statement that you have to use is what you have to decide. Along with that, you should also select the looping structures if at all, if you need anything which is repeated. Okay, so there you have to use looping structures. We have for loops and we have while loops. So you have to decide based on its functionality, where should you use for loop and where should you use while loop. So you have to decide that. Then after that, thinking of efficiency, which I have already told. So my dear students, please remember speed, effectiveness and performance is very, very important. Whenever I'm writing a program, these are the three important points I have to keep it in my mind. Okay, so my dear students, please remember, whenever I'm writing a program, say for example, if you're using a WhatsApp, imagine if you're opening the WhatsApp and if it is taking 1 hour, will I use it? No, definitely not. And if it is taking more than 6 GB or 7 GB, okay, the complete app in your mobile phone just to open, okay, the RAM, so will you use it? No, definitely you will not use it. Okay, so in the same way, whenever I'm writing any program, it should be very quick. It should take very less time. It should take very minimal amount of memory and it should be very effective. Only then I will be able to use it. Okay, so in the same way, so even your solution also should contain these properties. So these properties are directly related to the data structure that you choose. All right, so that is very important when you're coding the program. All right, so this is with respect to the coding part of your solution. Then after that, once you're done with the coding, so it is very important that have you done that coding properly? Is it meeting our requirement? Am I getting the exact output which I was supposed to get? So that is what I have to test. So fine. So I will test with the sample data that I have. If there is any mistakes, I will correct it. Or if I find any errors, I will understand the problem and I have to fix it. So that is the stage that we are in now. So if there is anything, you have to test and you have to debug. All right. So once it is done, so guys, we are moving to the next step, that is program documentation. Everything, whatever you have done, all right, the documentation is very, very important. Okay, let me consider an example and I'll tell you. Say for example, I'm working in a project. All right, so I'm in the middle of the project and suppose, unfortunately, I'll not be able to complete the project and I have to leave the project in between. So whatever I've coded, all right, so 8 months, I have given that to the team and I've left. But the next person who is coming to that project, so if he wants to continue my work, so he or she should be able to understand what I have done. So that is very important. So until and unless if I don't document it properly, that what I have done, so there will be a lot of chaos and confusion to understand what I have done. So for that reason, documentation is very important. It is also like, the manual. Say for example, whenever you take any book or any product, so you will get a manual, right? So that book explains completely about that product. So in the same way, I have to prepare a document or have to prepare a proper program documentation to explain in detail what exactly the solution that we have given. So that proper documentation is very, very much needed in this particular point of time. Moving forward to the next one that we have, implement the code. Yes, sir, we have done that in the previous state, but implement this code in the client's place. Okay, so that is very important. You have done that in your place and it is working fine. You have tested it. All right, but now you implement that in the client's place because the environment is entirely different and it will have a lot of different challenges. So when you implement it, if at all, if you have any issues, so you should be able to solve that particular issues. That is very important. Then after that, so guys, program maintenance. Suppose if there is any upgradations, if there is any challenges, so that issues you should be able to solve to the client. So that's what we call it as a program maintenance. This is how we solve a given problem with these 10 steps in detail. All right, I have taken a simple example to explain this. All right, but you can relate this to all the real-time problems and you can start analyzing the problem step by step and you can provide your own solutions to address the given problem. All right, so with this, we have come to the end of this problem solving steps or cycle. All right, moving forward to the next one that we have. As I told you in the beginning, suppose if I consider an algorithm. What is an algorithm? A step-by-step solution to given a problem. Okay, that's what I will call it as an algorithm. If at all, if I say an algorithm, okay, what is the good characteristics of an algorithm? So let's try to understand this. Point number one, it should be precise. Number one, it should be very precise. Okay, suppose if it is too lengthy and if it is too complex, we will not be able to give a justice and it is creating a lot of chaos. So keep your algorithm or the solution very precise. The second important point, uniqueness. In each line, you should be able to perform a separate single task. Okay, so that is what we call it as uniqueness. There should not be any repetitions. All right, so that is what I call it as a uniqueness. The third important point, finiteness. Okay, I should be able to count the number of steps that I have in the algorithm, and definitely it should have input and output. Okay, so this is especially a good characteristics of an algorithm. So that's what you need to remember. Whenever I say an algorithm, so please remember in mind that 5 important points. Number one, it should be very precise. Okay, number two, each step should be unique. Each step should perform a particular task. And number three, so it should have a finite number of steps. You should be able to count. Okay, so that's what I will call it as a finiteness, and definitely it should have an input and it should have an output. This is what I will call it as a characteristics of a good algorithm. All right, so moving forward to the next important point that we have. All right, so components of an algorithm. So basically, as I told you, whenever I consider a components of an algorithm, 3 important components will come. Number one, as I told you, the first one is input. All right, the second one is processing, and the third one is output. All right, so I have to have the inputs for a given algorithm, and I should be able to mention what exactly the task is being performed. That's what I will call it as a processing, and then I should have an output. So these 3 things are considered as a components of any algorithm. So let me not bore you guys by saying this. This is very simple. All right, so moving forward to the next one. Next one is all about the flowchart. A pictorial representation of step-by-step solution for a given problem is what I will call as a flowchart. So why do I need this flowchart? So you're writing the algorithm. Why are you going for a flowchart? That's very important that you need to understand. My dear students, when it comes to a flowchart, it's very important to represent any concept in a pictorial representation. So can you explain why it is required, pictorial representation? Say for example, I have not stolen a silver ring. If I say like this, what did you understood? Many of you will understand, take it in a different way. So I am not stolen a golden ring. If I say, okay, the meaning of what I'm saying is, I have not stolen a golden ring, but I have taken a silver ring. Okay, but you have taken it in a different way. This English kind of statements leads to a lot of ambiguity. To solve this ambiguity, so we need a lot of pictorial representation to convey the message very clearly. So for that, we have the flow chart. So with the help of lot of notations that we have, each notation has got its own meaning. So let us try to understand this notations that we have in the pictorial flow chart. First of all, we have start and stop. If I want to represent start and stop, so I will be using this shape, oval shape. Suppose if I'm representing any input or output, so I'll be using this symbol. And if I'm representing any process, if you are performing any activity, if you are performing any calculation, you will be using this symbol. All right, so this is what you need to remember. All right, moving forward. So suppose if I have this diamond shape, this is what we call it as a rhombus. Suppose if you are making any decisions, say for example, I'm using if statements. Okay, so I have yes or no. I have to take a decision. Suppose in that case, in that situation, so guys, you are using this kind of symbols. And then definitely to depict the flow of control systems, you will be using the arrow mark. So the arrow mark will tell you how exactly the flow is going, in which direction, top to bottom or bottom to top, or in which direction the flow is going, the execution flow, that is getting depicted with the help of this arrow marks. And also, so you will be using this symbol for annotations. And then lastly, if you are connecting, so you will be using the circle to depict the connector. All right, let's take an example and understand how exactly I can use these symbols. Yes, of course, you got introduced to these symbols. With an example, you will have a better clarity. So let's take an example and understand. Before that, if I'm writing an algorithm, so 3 things should be there. All right, the first one, I will call it as an identifier. Okay, I will be discussing about this identifier in detail, okay, from the next chapter. But as of now, you just remember, if at all, if I have any different parts in the algorithm, to give a name for that parts, I will be using something called names. Okay, that names is what I will call it as identifiers. Okay, different parts I will be having, say for example, I have a different parts in the body. So each part has got a name, right? In the same way, in algorithm, I will have a different parts. So for each different parts, I will be giving a name. So that's what I will call it as a identifier. Say for example, I have a variable. So if I want to give a name for the variable, definitely that will be treated as a name, that is identifier. All right. So like that, definitely you will have a variables, and then after that, so after having the identifiers, you will have a sequence. Okay, sequence in the sense as I discussed in the previous slides. So you will have the control statements, if statements, different types of if statements. All right. So we have simple if statements. Say for example, if you have only one if statement, so this is what we call it as a simple if statement. All right, this is not with respect to the Python, don't worry. But just to represent the simple if statement, I'm just writing. So simple if statement, you have if else, you have ladder if, you have nested if. So you choose to decide the sequence, what type of if statements you need. Then after that, so you have repetitions. If you want to repeat any task, so please use the looping statements, for loop or while loop. So based on the situation, so you can decide which type of loops that you can use. Say for example, if you want to satisfy the condition, please use while loop. If you want to satisfy the count, use for loop. So I will be discussing about this in detail, but as of now, when it comes to the repetition, if you are writing an algorithm, please remember, when it comes to the repetition in the sense what? Looping. So you have two different types of loop, for loop and while loop. So based on your requirement, you can choose the looping statement. That's what you need to remember. So as I told you, if you're writing an algorithm, so please remember three things will be there. So one is identifiers. Identifiers in the sense you are giving names to the different parts, okay? Or you are having a variable and you are giving a name for that variable, and assignments. So that's what it should come to your mind. The next one is sequence, the flow, okay? So you will choose the different types of control statements, different types of if statements based on your requirement. And the lastly, repetition, you will choose which type of loop that you have to use for a given problem. So this is the basic idea that you should have. Don't worry much about this. So if you know this much, this is more than enough. Moving forward to the example that I have. My dear students, I have an example here for all of you. In this example, I just wanted to write the flow chart, okay? So for to perform addition of two numbers, okay? If I want to perform addition of two numbers, how do I write an algorithm? I'll show you. Then after that, for the same problem, I'll also show you how to write the flow chart. So if you know the steps, try out at home with the different problems, okay? And try to write the algorithm for a number of given problems, and try to write the same thing for a flow chart also. All right, so let's try to understand for a given problem. So for this problem, how do I write the algorithm first? All right, so what is the problem that I have? I have add two numbers. If I want to add two numbers, first of all, I should have two numbers, right? So 6 and 4. All right, so this is the two numbers that I have. First of all, I should take that. Okay, so I should take that from the user, only then I can perform the addition. All right, so let's try to understand. So step 1, okay, first of all, I should start. That is the first step in your algorithm. All right, so fine. So first step, I'm starting it. So I'm very clear about it. So next step. So guys, step 2, observe here in the step 2. So do I have the number to perform addition? No. So for that, I have to take it from the user. So please understand, get two numbers, that is N1 and N2. I'm just giving the names to the value which I'm reading. So N1 and N2, I will call this as an identifier. Please remember, last slide, I have told you about identifier, all right? So N1 and N2, whatever the number that I'm getting, okay, from the user, the two numbers, I'm trying to store that in the N1 and N2. So fine, you have N1 and N2, two numbers. Then after that, go to the step 3. So observe here, I'm performing addition with the help of the plus operator, N1 plus N2. That result what I have, so I'm just trying to store it in the variable yes. My result of performing addition of two numbers, I'm storing it in the variable yes. Then finally, in the next step, I'll print the result yes. Then after that, I will stop. Okay, this is the algorithm, okay, to solve the given problem. What is the problem? Perform the addition of two numbers is the problem. So I'm solving that problem step by step. Okay, that's what I will call it as an algorithm. So now for the same thing, how do I write the algorithm with a given notations which we have studied in the previous slides? Observe here. So what is the first step that we have? We have start. Okay, so you all know this is the oval shape that we have to use whenever you're representing the start. Okay, so yes, I'm using the same symbol, same notation. Then after that, if I want to read any input, so this is the parallelogram that I have to use to read any input, okay? So for input as well as output, I'll be using the same shape which we have already seen, all right? So I'm reading N1 and N2. So fine, after that, so please observe here, I'm performing some calculation. I have to use this symbol to perform the calculation, all right? So S is equal to N1 plus N2. So addition is happening, some action is happening. So this is what I will call it as a processing. If you are performing some task, okay, that's what we call it as a processing. So here S is equal to N1 plus N2 is happening. All right, that's why I'm representing it in this particular symbol. Then after that, I have the result in S. Then I will use this symbol to print my result, that is S. Then finally, I will use the same symbol which I have used for start to stop the action. So this is how I will be writing the flow chart for a given problem, my dear students. So with this, so you got a brief idea with respect to the algorithm as well as the flow chart. Now, what is your task? Now you have to list out the different problems that you have. So for all the problems, try to write the solution, okay, or the algorithm for a given problem. And then for the same thing, same algorithm, please try to write the flow chart. All right. Keeping this in mind, moving forward to the next one, pseudocode. I don't have to tell you much about this pseudocode. Pseudocode is very simple. Whenever you're writing anything, it will be in a natural English kind of a language, English kind of statements. That's what we call it as a pseudocode. All right. For example, we have observe here, if students' marks is greater than or equal to 50, okay, display passed, else display fail. This is what I'll call it as a pseudocode. Whenever I'm writing any pseudocode, so it will be more of general, it will be in a English kind of a language. So that's what I'll call it as a pseudocode. It will not follow any particular language. So that's what you need to remember. All right. So moving forward to the next one. Whenever I'm writing a pseudocode, what are the advantages that I have? Number one, it uses the language which is easy to understand. Okay. That is the first important point and first important advantage. Second point, it highlights the sequence of instruction. What should come first and what should come next. The sequence, you will understand it very clearly in the pseudocode. All right. So next one is the structure is clearly visible and it can be easily modified. So you don't have to scratch your head much to modify the content that you have in the pseudocode because it's in a normal natural language. Okay. So that's what we find it in the last point, that is it can be easily modified. And what are the disadvantages that we have in the pseudocode? Please observe, not visual tool like flowchart. It's not a visual tool. So that is the first point. Suppose if it is not a visual tool, so you all know the advantage of visual tool, it creates a lot of ambiguity. Okay. So since it is using English kind of a language, so it is not visually represented. It creates a room for ambiguity. So that's the point that you need to remember here. And not accepted standard there is no particular standard that you have to write the pseudocode in this particular format itself. There is no particular clear format for it. So that's the second point that you need to remember. And only it can be tested on paper. You cannot run that and you cannot see the execution. You can just test it in the paper, that's it. All right. So informal representation of an algorithm. So this is how you can write the algorithm in an informal way. So to understand the sequence of the flow. All right. So this is what the drawbacks that you have with respect to the pseudocode. The next problem that I have is all about, my dear students, verifying an algorithm. What exactly verifying an algorithm is all about? So guys, you have written the algorithm, and the algorithm is working fine. So whether your algorithm is working as per your requirement, whether your algorithm is giving the expected output. So guys, this is very, very important. Point number one. Point number two, I have a problem. In a class, I have 30 students. So I will ask the 30 students to write the algorithm for a given problem. So 30 students will write the algorithm in different way. So guys, how do I choose the particular algorithm which is most efficient? So this is the two important points that I need to understand. So for that, the first one, so if I want to check whether the algorithm is working fine or not, so for that, we have a method called dry run. So guys, this dry run is a method which we use to test, okay, whether the algorithm is working exactly what is expected. And it is not ready for execution. It is only to test the logical mistakes that we have done in the algorithm. So for example, if I have an example like this, so guys, I will trace, okay, I will be able to write the trace table, how exactly it is working if I run. Okay, so for example, I have the for loop here. Okay, I have the variable here. Alright, so this for loop will run 1, 2, 3, that is 3 times. What does it mean? So please remember, whatever I have written inside this for loop, okay, these statements will execute 3 times. That's what you need to remember. So fine, how it is working? So let us try to understand. Don't worry about the syntax, though we have not started the Python for all of you, just understand the concept, that's it. So for loop in the sense, it is a loop. First of all, you need to understand it is a loop. What is the meaning of loop? Loop in the sense it repeatedly executes the set of statements. Okay, so what is that it is going to execute repeatedly? These 2 statements will get executed repeatedly. How many number of times? It executes 3 times. That's what you need to understand as of now. Alright, so fine. Let's understand this one by one. Okay, step by step. Observe here. So for is a keyword. Don't worry about it. It is doing its job. So its job is to repeat the execution. Okay, how many number of times? Please observe here. So now here I have to execute for 3 times. 1, 2, 3. So in the first iteration, the value of this number, this is a variable, number is a variable. The value of this variable is assigned as 1. As of now, the number is 1. Okay, so as of now, the number is 1. That's what you need to remember in the first iteration. So I'll go inside. Okay, it performs this operation. What is it performing? So number into 2. So guys, what happens? Number into 2. So observe here, val number into 2. So number in the sense, please observe. So what is that I have? So number value is 1. So 1 into 2 is 2. Right now, the value is, what is the value that I have? So the value contains, observe here, it contains 2. So that's what you need to remember in the first iteration. Then after that, print val plus 1. Okay, print val plus 1 in the sense, observe here, val plus 1 in the sense, it becomes 3. If I print, okay, the answer should be 3. So this is what I will call it as a dry run. So I have to write and I have to trace, okay, what exactly is happening in the first step. Okay, this is what I will print. Okay, 3 is what I will print in the first step. All right, so fine. After that, what happens? Because it should run for 3 times, right? So let me just show you. So in the next iteration, okay, so the number, okay, after 1, so it will assign 2 to this variable. Right now, in the second iteration, the value that I am storing in this variable is 2. All right, so fine. I will go inside. So what is this? In this step, what happens? So number into 2. So what is the value right now that I have? Number into 2. Right now, what is the value of number? So my dear students, the value of number is 2. 2 into 2 is 4. Right now, the value, what it contains? Value contains 4. So that's what you need to remember. After executing this statement, I'll go to this statement, val plus 1. Okay, so val plus 1. Okay, val plus 1 in the sense, I will just have 5. Okay, so if I print, I will be printing 5. That's what is happening in the second iteration. So in the third iteration, what happens? Let's see. Okay, in the third iteration, so please observe, number is getting assigned with 3. Okay, third time, in the third iteration, variable that is number is getting assigned to 3. So please understand that this variable contains 3. After that, it goes inside this. Okay, so right now, number, okay, into 2. So right now, what do you have in the number? I have 3. 3 into 2. So please observe. So you have this in the val. Right now, 3 into 2 is, so please observe, val contains 6. All right. Then after that, so whenever you are printing, so please observe, val plus 1. Val plus 1 in the sense, so you have 6 plus 1, that is 7. So this is what, the way that we are trying to solve and understand in each line, in each iteration, how it is working. So this is what we call it as a dry run, and we have to represent this in a table. That's what we call it as a trace table. Okay, you will understand how exactly each statement is working, how the program is executing. So you will also get to know, okay, where should I use what type of logic. So you will understand the essence of programming. Okay, so this is how you will improve your logic skills. All right, so this is all about the trace table that we have, the concept, and moving forward to the algorithm. As I told you in the beginning, in the last slide, if I have 30 different algorithms from 30 students, how do I select the particular algorithm? So guys, basically 2 important things that I will be considering. One is time complexity, another one is space complexity. So the algorithm what I have written, so it should take very less time and the algorithm what we have written, it should take very less space. Only then I will choose that algorithm. Okay, to understand the time complexity and space complexity, we need to understand the data structure in depth, which is not there for you. But as of now, please remember, if at all, if you have a beautiful data structure, okay, a particular selected suitable data structure for a given problem, so you can have very less time to execute that algorithm, and you can use very less space to execute that particular algorithm, is what you need to keep it in your mind. So this is what you need to do whenever you're choosing any algorithm. Moving forward to the next one that we have, this is with respect to the getting started with Python. Okay, but when it comes to the getting started with Python, I feel if you know this much is more than enough. Okay, because how do I use the different tools to use the Python? I will demonstrate live in my live class. Don't worry about it. But when it comes to this Python, so what are the advantages that I have with respect to the Python? So that's what I'll call it as the pluses. All right, the first one, that is easy to use. When I compare to any other programming languages, Python is very easy, very simple. Okay, so that is the first advantage that you have. The second one is expressive language. Sir, what is the meaning of expressive language? In one single line, you can perform many things. Okay, that's the advantage of using Python. So that's what I'll call it as a expressive language, and also it is interpreted language. Okay, when it comes to Python, it performs the compilation, and after that it interprets line by line. Okay, that's the advantage of using Python once again. And then after that, so it's completeness, and then it can be used in the cross-platform language. Okay, it can be used in multiple platforms. Okay, at the same time, that's what one of the major advantage that you have. So cross-platform language, and then after that, it is free and open source. You don't have to pay anything for it, and then you can have a multiple varieties of usage and applications. Especially as I told you in the beginning of the class. So my dear students, Python is in boom. Okay, with respect to the data science and machine learning and artificial intelligence. Whenever you say artificial intelligence, the major contribution, okay, that you can expect as a programming language is from Python. So that's what you need to remember. This is the advantages that we have if you are using the Python. And then I have some drawbacks also with respect to the Python. Let's take a look at that. It's not a fastest language. People say lesser library than C, Java and Perl, but nowadays it has got a lot of contribution to this particular language. A lot of libraries are available these days. I personally don't agree with this point, but as in if you are getting the new versions, libraries are very, very massive. Okay, with respect to the Python programming languages. So that's what I feel. All right, so moving forward to the next one, not strong on type binding. Okay, what is the meaning of type binding? Say for example, in any other programming languages, if you just write, okay, this is what we call it as a declaration. That is not required in Python. Okay, so after the writing a program, so during the execution, if you take a variable, you can just write like this. Okay, you don't have to specify the type of the data. Okay, during the execution time, this value will get binded to this variable. All right, so only then, so it will understand that this is an integer. Okay, so that is not strong in Python is what they are saying. And then not easily convertible to any other languages is what they're specifying. This is the different drawbacks that we have. But don't take these points seriously, because they have really worked hard to overcome from all these challenges in the newer versions. All right, so with this, I've come to an end of this session. So this is the basic things that I have. So I've not really stressed on these points, but if you know the basic concepts, this is more than enough. But from next session onwards, I want really to pay a massive attention to understand the concepts of Python. Exact concept of Python starts from the next session. Thank you very much.